Sambil tunggu yang lain ya Pak Reza. Assalamualaikum Prof Oki.
Waalaikumsalam warahmatullahi wabarakatuh. Pak Zaki.
Ya, saya Zaki Pak.
Nih, terima kasih banyak nih udah dikasih background-nya Pak. Nanti saya pakai background-nya Pak ya.
Iya, nggak apa-apa Pak. Ini kebetulan untuk dosen pengampu hari ini ada Pak Reza juga Pak. Nanti ada Pak Sri, mungkin joinnya agak telat ya Pak.
Ya Pak, silakan Pak.
Iya, nanti kita masih mulainya jam 10 kok Pak ini ya.
Oke. 13 menit lagi insya Allah Pak ya.
Iya, insya Allah.
Iya Pak.
Assalamualaikum Prof Oki, kedengaran nggak ya suara saya?
Waalaikumsalam warahmatullahi wabarakatuh. Salam kenal nih Pak Reza dan Pak Zaki nih.
Salam kenal Prof Oki. Pak Zaki makasih linknya ya.
Iya Pak Reza.
Sekitar 10 menitan lagi kali ya kita mulai ya.
Ya Pak, insya Allah.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning, everyone. Nice to have you here in today meetings, webinar. We have our honor guest professor from King Fahd University. First, I would like to introduce you all. His name is Professor Dr. Oki Muraza, ST MSc from King Fahd, King Fahd University Petroleum and Mining and Mineral.
Minerals.
KF UPM. He was graduated from Institute Technology Bandung from Chemical Engineering in 2001 and then continue in the Netherlands to finish his master and doctoral. His master accomplished in Technical University Delft in TU Delft and then continue his doctoral degree and accomplished his doctoral degree in 2009 from Technische Universiteit Eindhoven. So today we have the discussion and webinar in the title Circular Economy in Mining Industry. So Professor Oki Muraza, the screen and time is now yours.
Reza, ini langsung nggak pakai dari Pak Nofrizon dulu?
Langsung kali ya Pak, atau ada pembukaan dulu? Pak Nofrizon masih mute Pak.
Langsung aja nggak apa-apa. Oke, silakan Pak. Oke, monggo.
Terus ini bahasa Indonesia apa bahasa Inggris Pak?
Boleh dua-duanya kali.
Ya.
Bahasa Inggris preferably Pak. Ya, bahasa Inggris.
Udah muncul Pak ya, slide-nya Pak?
Oke,
Sudah Pak,
kelihatan.
sudah.
Ya. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
wabarakatuh.
Good morning, ladies and gentlemen. Thank you very much for the administration at the Material and Metallurgy Engineering at University of Indonesia. I would like to thank Professor Herman and also Professor Nofrizon and with the other instructors at Metallurgy and Material Engineering, Dr. Reza and Dr. Ahmad Zakiuddin. My name is Oki Muraza. Thank you very much for this opportunity. Inshallah, in the next 40 to 50 minutes, I would like to share some of our activities related to the circular economy, which is basically our activity and interaction with the local mining company in Saudi Arabia. Yeah, a bit about myself. My background is chemical engineering. Yeah, basically metallurgy and material engineering and chemical engineering are also the relative of mechanical engineering. Yeah, one of the eldest major in engineering. After I graduated from university, I worked in offshore in Indonesia, and then I got scholarship to Netherlands for master and my PhD. And since 2008, I have the opportunity to work in Middle East, in UAE for 2 years, and then now in Saudi Arabia about 10 years. Alhamdulillah, in the past few years, I have the opportunity to have better interaction with Indonesia because we have several programs called World Class Professor. So I spend some time at different universities, including these universities. Yeah. One of our activity basically to run and to execute industrial project with companies. Alhamdulillah, according to the university administrations, I'm one of the most productive experts in terms of securing funding. As a consequence of our activity, we need also to work a lot on the publications. Now I'm considered to be like top 6 in the terms of publication at KFUPM. And since 2015, most of our activities are merely with the company. So with company, they have another demand, which is basically securing the intellectual properties. So a bit about our location. We are located in the east of Saudi Arabia. Most of you are familiar with the west of Saudi Arabia. There, the west we have Makkah and Medina, and in middle we have Riyadh, and we are in the east basically. So in Indonesia, maybe our province is like Cepu or Duri, yeah, because mostly the center of economics is from oil and gas. Once they have the oil and gas, of course, they have energy to produce something else. So they built another company somewhere in 1978, so-called Sabik, by utilizing the cheap natural gas. And then also with that energy, there was another company developed for mining, because mining is also energy intensive industry. So this is called Ma'adan. So some part of my presentation today is basically our interactions with this company, yeah, Ma'adan. And then a little bit about my activities. Basically, I'm working on the material sides. We utilize materials for, we use mostly oxide.
Oh yeah.
As catalysts for hydrocarbon conversions. Yeah. So for the oil company, we developed oxide for upgrading, heavy oil upgrading, catalytic cracking, and then for the downstream company, we developed oxide catalysts for CO2 reforming of methane, methanol to olefins, etc. As I'm also from Indonesia, I'm also interested with some developments in bioeconomy, how to monetize our natural oils, yeah, such as palm oil, etc. So if we see our country, we can see that we imported many products. Yeah, so we produce mostly raw materials. Yeah, oil, gas, and then coal, and then crude palm oil, and then we imported quite a number of products, including the minerals. Yeah, including minerals and materials. So basically, within this presentation, we would like to give our motivation for ourselves. How can we produce more materials and chemicals from local resources? Yeah. And then also we would like to apply these materials for energy fields mostly, as a sorbent or as a catalyst. Mining industry is one of the backbone for Indonesian economy. As you can see here, we have the activity basically to get the metals from mining industry through the mineral processing, metallurgical processing, and then we have the fabrications. However, unfortunately, most of our activities are basically towards the beginning of this mining process. Yeah, we do not have that much the material fabrication and product manufacture. With the needs that we have recently, the circular economy in every field, we need to think how can we have the complete picture by adding the circular economy concept into our mining industry. So in this case, we need to have the we need to apply the concept recycle, remanufacture, repair, and reuse. Yeah. And it's also important to relate the mining industry with other industry around us, yeah, because mining industry also receive a lot of energy, yeah. So it's also strategic to think how can we um, have the circular economy not only for mining energy itself but also for mining and energy. So in Indonesia, for instance, we have a number of company here which are in the mining clusters, and then it's strategic to think how can we utilize the waste, or we need to do repurposing the waste products in such a way that it can be utilized. Hopefully, it can be utilized by the energy company. Yeah. We have a number of energy company in which that they need quite a number of materials, let's say oxide materials, which can be obtained from circular economy, yeah, from recycle, remanufacture, etc. In Saudi Arabia, we have also the similar need. So we have been in touch mostly with the energy company, which is our neighbor. Actually, our university is the institutions which is governed by the Ministry of Energy in Saudi Arabia. And at this moment, our president was the senior vice president of Saudi Aramco. So we have to think how can we utilize this concept in order to strengthen the energy and mining industry. So this is basically our project. How can we repurpose the waste from mining industry, which are abundant and cheap, for energy company. There are a lot of waste materials from mining industry which can be utilized for energy business. Yeah. So in this loop, you can see that mining companies are producing waste. Yeah. From the waste, we can have a new business venture, and then this new business venture will produce some materials which can be used by energy companies. Yeah. So this is some of our work related to waste materials from mining, in which that we classify the materials and then we try to uh, contribute on the development of technologies which are suitable to convert the waste materials for catalysts, sorbents, and in the future maybe as enhanced oil recovery agents, etc. We are going to see a number of waste from our mining industry. Approximately about 50 to 60% of Indonesian energy is coming from the coal. And as you can see here, the coal is producing so-called fly ash. Yeah. This fly ash is basically strategic materials which can be utilized for some classical purposes and also some new applications. Yeah. It can be used in the road construction, material building, and some other materials, but this is also strategic for numerous applications, yeah, geopolymers, etc. And then we also see the waste as a low-cost materials. Yeah. We have seen, I have visited quite a number of universities in which that most of the complaints basically around the materials for research. Yeah. So in Indonesia, we are lucky that we have a number of mining companies in which that they are producing waste. Yeah. It can be in the form of tailings, or it can be in the form of slags, etc. So these are basically cheap and abundant materials around us, as long as we have access to this waste. One of the classical utilization of these waste materials is basically the building materials. Here we can see that the slag materials are applied for building materials. Yeah, of course, this is not a recent discovery. This has been done for a while. So one of the potential application is in the building and construction materials, as long as we have checked whether the materials is containing dangerous or poisonous materials, or and then after that we can try to convert them to building materials. The other applications which are also quite famous is the utilization of the waste for ceramic industry. Yeah. So we can produce a number of materials, as you can see here, which can be obtained from the slag. Yeah. We can develop slag with some other additives, and then we have again refractory materials which can be applied in number of applications. Recently, we have hot topics around the CO2, yeah, CO2 utilization. Here you can also see that the slag or the waste from titanium production was also treated and then processed and modified by different ways, by pyrometallurgy, by hydrometallurgy, etc., in such a way that we can have materials which can be applied for CO2 utilization. I depicted some of the recent works. For instance, here you can see the slag that we have, which has been treated and then further modified with the nickel, and then the materials are having unique properties which can be applied as a catalyst for this reaction. This is called dry reforming, or CO2 reforming of methane, in which that we try to convert two greenhouse gases into something useful. This CO plus hydrogen, we call it as synthetic gas. This is basically one of the 7 feedstock for petrochemical industry. So we start observing that some of these waste materials can be used for this purpose, for catalysis. So this also stimulate us in developing projects or activities with the company, with the mining company. One of the challenges that we have from the local company is the very large lake of red muds. Yeah. Red muds is basically the waste or the byproduct of aluminum mining and alumina production. As you can see here, we start the aluminum mining with bauxite, and then size reductions, and then we have hydrometallurgy until basically we leach the aluminum, and then the aluminum will go further in the other steps until finally we get the hydrated alumina, and then we have large materials which we call as a red mud. So this is a mud basically with reddish color, the red coming from the iron oxide that we have in the red mud. Yeah. So this is basically our homework from local company. They have a very large lake. You can expect that this 1.8 million tons uh, per year of alumina, and then approximately a similar amount of red mud is being produced by the company. Yeah. At this moment, the current best practice is basically just to mix the red mud with the other stream in such a way that the lake will be close to normal pH, to the pH around 7. Yeah. But of course, we have a lot of activities which can be pursued in order to utilize this red mud. This is the cover of prestigious science magazine by Triple AS. Yeah, this special issue about mud. And not only this, the utilization of red mud is also strategic in a way that we prevent the catastrophe. Yeah. So there was accidents, if I'm not mistaken, in Brazil in the past, in which that the dam of red mud collapsed, and then we have they have the national tragedy because of the release of red mud into the society. Of course, there are a lot of efforts to recover something from red mud. We can see in the next few slides, there was an effort to, for instance, to recover the iron, yeah, by using magnetic separations. So this is basically to separate the iron elements from non-magnetic or less magnetic. In this way, we can produce additional income from the iron and also some other residue. Yeah. And then with the major techniques that we have in extractive metallurgy, such as pyrometallurgy, for instance, there was also an effort that basically we can add reductant. It can be coal, it can be biomass, in such a way that we can have reduction reactions for red mud. This is also another way to recover something from red mud. This is pyrometallurgy recovery, basically by applying heat, yeah, by applying thermal treatment. By this approach, also we produce something from red mud. And then there is also effort to apply hydrometallurgy. Yeah. Basically, we try to utilize some knowledge on aqueous chemistry in such a way that we can leach or we can recover something from red mud. Yeah. This is basically things that we have in our lab. Unfortunately, some of our manuscripts are still under review. So hopefully in the future, I will get the opportunity to share some of our activities to recover something from red mud. We are interested in a number of components, yeah, because surprisingly, some of the red mud that I obtained from Indonesia are also containing a lot of alumina. Yeah, that's the first thing. And then from some red mud materials that I received from Middle East, it's containing a good percentage of titanium, etc. So it seems that even though the process is a standard buyer process, depend on the location, we may have the difference. But mostly the main components of red mud is basically the alumina, and then titanium, and also iron oxide. Yeah. Fortunately, we have current activities in utilizing this oxide. We have some processes to utilize silica and alumina, iron oxide, and also the titanium. Yeah. So basically, we have the first research activity around alumina and silica. Yeah, and then after that we expect to utilize also the iron oxide and also the titanium that we have from the red mud. Yeah. Hopefully, some of our works will be accepted soon. So in the future, I can share some of our results by converting red mud into catalytic materials. And then the alumina itself, it's a very established materials. Yeah, in refinery, we utilize these materials a lot. This is one of the cheapest and robust oxide material for catalyst support. Here you can see different alumina which can be obtained and applied as catalyst, yeah, and catalyst support. Basically, these days, the industry prefer to use gamma alumina, yeah, because this materials is having better hydrothermal stability, and also the specific topological properties are better than the previous generation ETA alumina. Yeah, so we have a lot of processes in refinery in which that we utilize the gamma alumina either as a main catalyst or as a catalyst support, mostly catalyst support. Yeah, this is the reforming, for instance. Reforming, we also utilize alumina as a catalyst. We in our lab we also have some reactions in which that we need alumina. When we receive one of the batch of red mud from Indonesia, which contain a lot of alumina, and then we need to adapt and adjust the applications towards alumina. For some batch of red mud that we receive with low content of alumina, and then we utilize it mostly for the silica and iron oxide, which are contained in the red mud. This is basically the summary of our activities related to the red mud. Hopefully, yeah, some of our activities will be published soon, so I can share the published papers in the next opportunity, inshallah. And then we have also the concern of utilizing the other type of waste. Yeah, we have in Indonesia. Indonesia is one of the largest exporter of coal, and then we use coal as a basically one of the primary energy in Indonesia, and then we produce so-called fly ash. Yeah. This is basically ash, which can be utilized for numerous applications. Recently, we also been in touch with the university, which try to utilize the fly ash from palm oil. Yeah. So normally from the boiler that we have in public kelapa sawit or palm oil mills. So these are also ongoing activities. We try to utilize the oxide from fly ash by chemistry in such a way that we get the geopolymer. Yeah, this is basically inorganic polymer, which can be utilized as either catalyst or sorbents in chemical industry. In Indonesia, it's also important to think about how can we have loop between the circular economy in mining industry with other fields. Yeah. For instance, at this moment in Indonesia, we have a national program in bioenergy in which that we try to optimize the energy coming from palm oil plantations. Yeah. Here you can see that we can utilize some of the materials, oxide materials, either from mining or from palm oil. In terms of in this case, we utilize the silica and alumina, which can be utilized as a catalyst and sorbent in one of these companies. Yeah. This is something which can be pursued in the future because we have mining industry in Indonesia. We have also palm oil industry, and we need energy and the materials both in Indonesia. The other strategic things that we have in Indonesia is the national program for biodiesel. Yeah, this is called B30 now. 30% of biodiesel mixed with the conventional diesel from petroleum. And then the government also set a target in 2022, we are going to have B40. So it is also strategic to try to utilize some of these materials for these activities. So we can try to apply some of the oxides that we have from red mud, from fly ash, and from the other slags and tailings, maybe, which can be utilized as a oxide materials for this program, biodiesel B30. And after the pandemic, we learned that many jobs disappeared from the society. In US, they reported that 40 million people are basically losing jobs, and in India, more than 120 million. Indonesia, with the size which is quite similar with US, with 270 million population is also suffering. So we need to create jobs. One of the natural resources which can be tapped, basically the mining and also the natural gas. So this is some of our activities related to the development of new economic centers from natural gas. In East Natuna, we have very large resource of natural gas, which contain high content of CO2. CO2 can be 70%. But this is very large resources which can create jobs in Indonesia in the near future. So we also try to apply some of these materials from the waste, from slags and from tailings, which can be utilized as a catalyst for these reactions. Yeah. As you can see, this is the CH4, methane, and CO2 that we have from the gas well, which can be converted by utilizing these waste materials from mining to get the CO and hydrogen. This CO and hydrogen basically can be utilized again to get products such as methanol, olefins, or aromatics that we can sell to the society. So this is the CO2 reforming of methane. Recently, there is also initiative to produce DME, dimethyl ether. This is also strategic fuel for Indonesia because at this moment in Indonesia we are importing LPG, very high import. It's approximately 77% LPG that we use in Indonesia is basically imported from abroad. So basically, we try to get DME, dimethyl ether, from natural gas by utilizing these oxide materials. And then the other resources that we have in Indonesia is waste. Yeah, this in addition to mining waste, we also have a waste from agricultural field. We also have a lot of agricultural waste, which can be converted to energy by utilizing this waste mining. Yeah. This can be targeted, for instance, if we have the iron oxide from the slag or from the tailings or anything from mining, which can be converted as a catalyst for waste for energy. Yeah. This is basically biomass gasification. In biomass gasifications, we try to convert the solid waste. It can be agricultural waste, or it can be the MSW, municipal solid waste, to producing gas, CO and hydrogen. However, the problem is we always have tar. Tar is basically the byproduct, the unwanted byproduct, which can plug the systems, etc. So we can utilize our waste basically as a catalyst in order to have the tar decomposition or tar cracking. This is also ongoing activities that we have. We have the nickel, and then we have the iron, and we are trying to employ the oxide from the mining waste for gasification. This is the some other details about the composition of tar, basically by using the iron or iron oxide that we have. Yeah. Because this tar is creating problems. Yeah. Basically, we need to develop systems, mild process in which that we can have prospective process. So it will be attractive. The iron-based materials, they are basically cheap, and then if we can get it from the waste, it will be beneficial for us. So this some of the iron oxide that have been applied basically for reforming of biomass. Yeah, so we try to get the synthetic gas from biomass by utilizing the oxide materials, iron oxide with silica, iron oxide with nickel oxide and silica, etc. So these are the materials which can be obtained easily from the mining waste. Yeah. And then we also have the interest with the robust oxide. Silica and alumina are very strategic for a mild process, but for extreme process, for instance, the process with supercritical water, etc., we need to have very robust oxide. Yeah. So in this case, we are considering the zirconia and iron oxide, etc. Basically, some of the oxide which can stay at very harsh condition, high pressure and high temperature. So, for instance, this is in supercritical water. There are many works can be done in supercritical water, such as the decomposition of plastic waste, the upgrade of heavy oil, etc. Basically, this is also something which can be pursued in the future by utilizing the waste materials which may contain this either zirconia or iron oxide, because they are robust and stable materials. So to summarize some of our perspective and activities, in Indonesia we have challenges in energy because we have a very big portion of energy from import. We need to have more energy being produced in Indonesia. And then at the same time, we have also environmental problems coming from different fields, including the mining industry. So we can try to utilize or to modify some of the waste from mining industry, which can be applied in numerous fields. Yeah. In my case, as we have facility mostly for catalytic reactions, for such as catalytic cracking, um, and then we have also CO2 reforming of methane and other CO2 utilization. We try to use this mining waste basically as a catalyst and sorbent. Yeah. In the future, we expect that the energy and fuels can be produced over the mining waste and also agricultural waste. Yeah. Both of them are abundant in Indonesia. So in the future also, we expect to have more collaborations to apply these low-cost materials for different activities, including the energy research. We can try to utilize the red mud, yeah, the materials that we are now collecting from different companies, and then some low-cost materials, iron sands. Yeah, this iron sands we also have a lot in Indonesia. I receive iron sands from Aceh until Papua, and then also some other waste, also very strategic, fly ash, etc. With this, I would like to thank the upper administrations at the Teknik Metallurgi dan Material at University of Indonesia for giving me this chance. Thank you for your attentions, and I hope that we can have further discussion and potential collaboration from this meeting. Thank you very much. I would like to return the floor back to the organizer and moderator. Thank you so much.
Okay, thank you, Professor Oki, for your very interesting discussion, yeah, in the field of secondary materials processing. So in our department, we also have Professor Joni Wahyuadi and Dr. Sri Harjanto, who really expert in this term. So we can now open our discussion and Q&A session. Is there any question from the audience? Maybe my senior, Bapak Sri Harjanto.
Okay, thanks, Dr. Reza, for permit me to give some comments, and of course, Professor Oki, thank you very much for your availability to share your research in the university. I hope that the materials or the research that you share for us inspire our student and our lab to to make some study related with this secondary resource. I have a question actually for Dr. Oki. How do you have any collaboration with Indonesian counterpart for this secondary resource processing or circular economy? That's first question. And then actually in terms of catalytic, I would like to know the prospect of iron-based catalytic materials for application, for example, in oil industry and for mining. Would you like to give us some insight about that related with iron sands for the cheap catalytic materials? Thank you.
Okay, thank you, Dr. Sri Harjanto, for your question. Maybe Professor Oki, you may answer, or we wait for another question from the students. Maybe if you have any question, please raise your hand or maybe type your question in the chat column. I would like also say hello to Professor Winarto. Hello, Prof. Win.
Halo, Assalamualaikum.
Waalaikumsalam, Prof. Win.
Ya,
Apa kabar?
baik. Saya
Ada
memang
pertanyaan, Pak?
Just see first ya.
Okay, thank you, Prof. Win. Okay, Prof. Oki, maybe you can answer the question.
Yeah. Thank you so much. Thank you, Pak Reza and Pak Sri Harjanto. Yeah, about the collaboration with Indonesia. So far, we have collaborations for collecting some of our red muds. Yeah, so we start to receive some red muds basically from Indonesia, and last summer I have several meetings with the Mind ID in Jakarta, but there is no formal collaboration yet. So in Saudi Arabia, we have collaborations with the local companies, Aramco, and we are engaging with Ma'aden. But with Indonesia, we do not have formal collaboration yet. So I hope that in the future we can do something together, because I think the funding from Saudi Arabia, it's easy to be released with the local institution. And similarly also in Indonesia, if we have the collaboration with the local companies in Indonesia, it's better to have the engagement with the Indonesian university, because the funding, it's easier to be released for the local institution in Indonesia. So I think this is something that we can pursue in the near future for different ways. For instance, in such as Redmart and others. And then about the iron oxide itself, we have a number of reactions. We may try to utilize the iron base for the sulfur sulfur removal in refinery. And then in our case, what we have with our graduate students, basically we mix the iron oxide with some other oxide. So we try to make a composite, ceria, zirconia, alumina, and iron oxide. And then we applied in heavy oil upgrading. This in Saudi Arabia, we have half G, in which that they have heavy oil. And in Indonesia also, basically in the future, we expect to have also heavy oil coming from South Sumatra. So I used to visit one company, Medco, I think in the past, they have heavy oil around South Sumatra. So this is something that we need to think in the future. We can apply the iron oxide to upgrade the heavy oil in order to produce lighter fuels, and then the lighter oil can be transported or can be further processed in our refinery in Indonesia. And there are many possibilities basically for iron oxide, because we also use this iron oxide, for instance, for gasification and some other processes. Yeah. So like to return the floor to Pak Reza.
Okay, Prof. Okay, thanks for your answer. I have a question from audience. Can we receive your presentation file or maybe your detailed contact if we or our student have a further question in the future? Is it possible, Prof. Oki?
Yeah, sure. So basically, after this, I will share my slides either to. I have some. I contact. I have the WhatsApp of Pak Sri Harjanto, Prof. Herman, and Zaki. Yeah. So I can share with one of the materials, and I'm willing to have further discussions. Actually, I live nearby the University of Indonesia in Depok. Normally, I visit the university for exercise over the weekend. Normally, I'm in Depok in June and July, almost every year. But this year, there is no flight because of the pandemic.
Yeah.
Thank you, Prof. Oki.
Yeah. Thank you, Pak Sri.
Thank you, Prof. Oki. We are waiting for your visit maybe next year if the pandemic is already over. Then we can have a nice meeting face to face, maybe, yeah, perhaps. And I open the next question for this session. Okay, I have a question from the chat. From student Ahmad Fatih, I want to ask, we have just learned about titanium processing, but not yet to learn about titanium scrap or slag recycling. Do you research about recycling or reprocessing the titanium slag, sir? If yes, maybe you can tell us a bit the recent development of titanium recycling, and in your which part of titanium processing that can be improved more. Thank you so much for your explanation. So he asking about your experience in titanium slag recycling, Prof. Okay.
Thank you, Pak Reza and Pak Ahmad Fatih or Mas Ahmad Fatih. I have interest to get also the waste from titanium company. We have the contact with the titanium company in Saudi Arabia, but so far I haven't received any material from them yet. So maybe in the future we will think how can we utilize the titanium slag or titanium waste. But so far we are still waiting for the materials because so far we have the relationship with the two companies in Saudi Arabia in which that they provided us basically the waste, the red mud, yeah, and then we analyze the red mud and we try to modify. We have the physical modification and also chemical modification for the red mud that we receive from the local companies. But for the titanium, not yet. We are still waiting for the first slag that we have that they may send us. And after that, we will do analysis, and then we will pursue with the two strategies, either physical or chemical modification.
Okay. Hopefully the question is already answered, yeah, Mas Fatih. Now I give back the opportunity to the audience if there still any question. No one? So maybe we can end this session by
There is another
saying,
question, Pak Reza.
oh, there's another question.
Yes.
Which one is it?
From Rafael Setiawan.
Oh, Rafael, sorry. How crucial is secondary mining process in today's mining industry? Should it be a mandatory practice for mining companies? From Rafael Setiawan.
Yes, very interesting question from Mas Rafael. Yeah, in our discussion with the local company, basically we learned that at this moment they are not considering the waste as a source of income. This is the issue actually. Basically, the mining industry is very profitable business. Yeah, in a way that with the current process, they have a very good margin and very good profit basically. So. The only concern is that the environmental regulation, yeah, with the worldwide trend at this moment to have a better approach to our environment. Basically, this is basically the driving force for the mining company to invest on the circular economy, in the recycling and reuse. Yeah. So at this moment, they are not considering the secondary materials as a source of income yet. That's the issue. So we have to develop technology in a way that it will be beneficial, not only by reducing their environmental burden, but also to generate profit, because for this kind of companies, mostly they are concerning about the profitable process. So there are a lot of approach basically in the materials that we are having now in the some efforts to utilize red mud, for instance. But some of them are more expensive than just leaving the red mud just as with the very large lake of red mud. But in the future, with the trend that we have to take care of the environment, there will be more environmental legislation which will motivate the companies, in the mining companies, in order to invest more in the secondary materials. So there will be drive from environmental issues. There will be new environmental regulations in a way that there will be opportunity for us to spend some time with these waste materials until finally after some time there will be technology which will generate some money. At the beginning, it is more responsibility for them to reduce their footprint to the environment. But in the future, we expect that once we establish the good technology, which can be scaled up and it can be applied industrially, and then they will consider also as a source of income. Yeah. So this is the only concern, the perspective that the waste is not really an income. So as long as they don't have problem with the environment, then it should be okay. Yeah. But the trend is now that we need to consider the waste in the loop. Like for instance, in energy company now there is a issue about the carbon trading, carbon tax, in a way that we need to handle the CO2 which is produced from every process. So similarly, the mining companies also is going to face similar challenges. Yeah, I think this is some of things that we observe. Rafael, thank you, Pak Reza.
Okay, thank you, Prof. Oki. Mas Rafael, I hope you already satisfied with the answer because it's already fully explained. So, is there any more questions? Pak Zaki, do we have any picture for this session or no?
Okay, if we have finished this session, then we can take a picture together.
Okay, before we take a picture, maybe I give one more chance to the audience. Maybe the audience still have any questions. Is there any questions? The last chance before we end the session. No one? Okay, thank you very much, Professor Oki Muraza from King Fahd University. Thank you for your time and your sharing and discussion. Thank you for the audience for coming in today's webinar. And for the organizer, Dr. Zaki Yudin, and also for other participants. Now I will give the time to the organizer, Mr. Zakiuddin, please.
Okay, I guess we can take a picture together. So I will need to ask you to open your video, to turn on your video. Okay, there are 3 pages and we will take a picture all pages one by one. Okay. Cheers. Smile. One more time. Okay, done. Thank you very much, Prof. Oki, for the nice lecture you have.
Thank you, Prof. Oki, and see you in the near future, yeah, Prof. Oki, and we still have contact maybe in WhatsApp or other media.
Thank you, Pak Reza, Pak Zaki,
Thank you.
Pak Sri Pak Prof Winarto, Pak Prof Herman, dan Pak Novrijon, semua sivitas akademika di Departemen Teknik Metalurgi dan Material UI. Saya tetangga Pak, jadi hopefully that from Depok I can visit the university easily, inshallah.
Yes, Pak.
After the
Prof.
pandemic.
Please come to visit us.
Thank you, Prof. Oki.
Terima kasih Prof Oki. Tetap
Banyak,
kontak
Pak.
nanti Prof.
Halo Pak.
Ya Pak. Oke, terima kasih banyak. Mungkin bisa ditutup Pak Reza.
Baik, dengan berakhirnya sesi foto hari ini, kami ucapkan terima kasih kepada seluruh partisipan. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Sampai ketemu lagi di visiting profesor webinar yang lain, dan selalu ikuti terus juga. Mungkin link YouTube-nya ada nggak Pak Jaki? Nggak ada ya?
Ada nanti.
Ada nanti. Oke, terima kasih. Assalamualaikum semua, sehat-sehat.
Waalaikumsalam.
Waalaikumsalam. Makasih Pak.
Makasih Pak Oki, makasih para mahasiswa ya yang sudah datang.
Terima kasih Prof.
Terima kasih.
Makasih, Prof.
Makasih.
Prof.
Makasih Pak Win, makasih Pak Sri, Pak Wahyu Haji, Pak Zaki. Izin live ya.
Izin live juga.
Saya juga izin Pak ya.
Ya, terima kasih Pak Oki.
Sama-sama Pak.